Welcome to The Explainer. If you're a health tech innovator, a developer, or a product manager trying to build the next generation of wellness applications, well, you are in exactly the right place. Today, we're laying out a complete technical playbook for how to build a wearable-integrated AI health coach app that's truly ready for the landscape of 2026. Because, let's be real, we're moving way, way beyond simple step counters here. Okay, let's dive into this. To really understand why we're building this, we have to talk about the immediate business and clinical value. The demand for continuous, intelligent patient engagement is just absolutely skyrocketing right now, and the data totally backs this up. Deploying digital health tools correctly is driving up to a 30% improvement in patient adherence to treatments. That's massive. Plus, it's causing a 20% reduction in hospital admissions. On top of that, 62% of patients actively prioritize having clear, ongoing communication with their care providers. They don't just want another app sitting on their phone, They want a proactive companion. So, here is our roadmap for today. Number 1, the AI Health Coach vision. 2, mastering wearable data integration. 3, designing autonomous AI agents. 4, the privacy-preserving framework. And 5, your 2026 development roadmap. Don't worry, it's a complex engineering task, but we've got a clear step-by-step masterclass to get you through it. Section 1, the AI Health Coach vision. Like I mentioned, we're no longer just logging activity. We are providing real-time, hyper-personalized guidance. To compete in 2026, your app needs to automatically generate training plans that adapt on the fly, based on, say, a user's fatigue levels or recent performance. It needs real-time motion tracking using computer vision, literally correcting a user's posture mid-squat during a workout. It should feature automated diet recommendations and use predictive analytics to actually forecast performance outcomes. It's a complete shift from passive data collection to active predictive coaching. And why does pushing the boundaries on these features matter so much? Because when you connect these capabilities back to your stakeholders, the results are just undeniable. Proactive, AI-driven follow-ups directly reduce 30-day hospital readmissions. Not only that, but they also boost patient satisfaction by 22%, while providing real-time clinical alerts. You're building a tool that quite literally saves lives, while saving massive amounts of administrative time. Let's move to Section 2 and see how this builds. Mastering wearable data integration. Right out of the gate, developers hit a wall of fragmentation. You really have to draw a clean line between the two major ecosystems here. On one side, you've got Apple Health's walled garden. It's highly mature, very secure, and mobile first, but it restricts data access strictly to the local device. There is no cloud API. Then, on the other side, you have Health Connect. This is Google's unified API trying to wrangle the totally fragmented Wild West of Android wearables to normalize data across different services. Because of this massive divide, your architectural planning is everything. Apple Health essentially forces you to build a mobile bridge. Meanwhile, devices like Garmin, Aura, and Fitbit rely heavily on their own cloud APIs. If you don't create a unified data schema across all these devices, your AI simply won't know how to compare, say, an Aura sleep score with a Fitbit sleep score. It's apples and oranges. Normalizing this data into one unified layer from day one will literally save your team months of painful engineering and maintenance time down the road. Think about the continuous flow of data here. It starts right at the edge with IoT sensing devices, like a smartwatch or an ECG monitor. From there, it flows through a base station or mobile device up securely into the cloud via a relay network. Once it's in the cloud, it's processed and delivered as actionable, real-time insights directly to the medical staff or right to the user's dashboard. It's just a dynamic, continuous pipeline. Section 3, designing autonomous AI agents. Time to build the brain. Now, what's really interesting about this setup is how the core components come together. An autonomous agent isn't just a simple chatbot responding to a prompt. It requires a context manager. This is huge because it retains longitudinal patient memory, meaning if a patient reports sleep issues 3 weeks ago, the AI actually remembers that and factors it into today's conversation. Combine that with a reasoning engine that mixes strict medical rules with generative AI, plus connector APIs like HL7, FHIR to seamlessly talk to electronic health records, and wow, you have a truly intelligent system. But remember, autonomous definitely does not mean robotic. The user experience has to be rooted in trustworthy engagement. Your AI needs to calibrate its empathy and tone perfectly based on the user's emotional cues. And crucially, this is a big one, you must always include clear boundaries and a human-in-the-loop escalation path. If the system detects a severe health anomaly, it needs to instantly escalate the issue to a real human clinician for safety. No exceptions. Section 4. The Privacy-Preserving Framework. Frankly, none of those amazing AI features matter even a little bit if your app violates HIPAA in the US or GDPR in Europe. The ultimate challenge is training your AI without exposing raw health data. This is exactly where federated learning comes into play. Think of it this way. Instead of sending all your private health data up to the cloud to make the AI smarter, the AI model actually travels down to your phone. It learns from your data locally and then only sends the newly acquired learnings back to the cloud. The private raw health data, it stays safely locked on your edge device. Now, when data absolutely must be processed in the cloud, we use homomorphic encryption. This is essentially the ultimate safeguard. It's a cryptographic technique that allows the AI to perform complex math and analytical operations on the health data while it remains completely encrypted. So the AI does the work, provides the insights, but it never actually sees the patient's sensitive numbers. It's pretty incredible. So the crucial point is that developers need to choose the right balance of security versus model accuracy. When you weigh these techniques, federated learning is great because it prevents data transfer, but it does require high computational power right on the user's smartphone. On the flip side, differential privacy, which protects individual data points by adding mathematical noise to anonymized metrics, is highly secure but can slightly reduce the accuracy of your AI model. You really have to architect the right mix for your specific use case. And listen, compliance in 2026 goes far beyond just stopping data breaches. Under the upcoming EU AI Act, health AI is categorized as high risk. That means you'll be required to conduct rigorous data protection impact assessments. You need strict access controls using AES 256 encryption and TLS 1.3. And perhaps most importantly, mitigating algorithmic bias is no longer just a nice-to-have or an ethical guideline, it is a strict legal mandate. You have to prove your algorithms are fair and transparent. And this brilliantly illustrates the payoff. When you integrate these AI models and privacy safeguards directly into a modern, event-driven API architecture, the performance gains are massive. The AI-driven architecture completely outperforms traditional baselines. We're talking drastically reduced API response times and significantly faster alert delivery times. You are getting higher security, smarter insights, and faster performance all at once. Section 5. Your 2026 Development Roadmap. Let's talk game plan. Here is how you chronologically guide your build process. You always start with market research and UX strategy. Then, and I can't stress this enough, you must lock in your wearable data and API architecture integration. You have to get the plumbing right before you move to step 3, which is integrating your AI models and edge training. Once the brain is in place, you move to rigorous penetration testing and compliance checks, followed finally by your App Store launch and continuous monitoring. Now, to keep those development costs down while maximizing your feature velocity, you need to be strategic. Start with a targeted minimum viable product. Use cross-platform frameworks like React Native or Flutter so you aren't building everything twice for iOS and Android. Leverage open-source healthcare plumbing components wherever you can, and absolutely build hybrid cloud and edge pipelines to keep those heavy AI server computation costs manageable. Ultimately, what you should take away from this explainer is that combining normalized wearable data, empathetic autonomous AI agents, and ironclad privacy frameworks doesn't just build a successful app. It creates a continuous, proactive, life-saving digital health coach. It fundamentally changes how we interact with our own well-being on a daily basis. So, I'll leave you with this final thought. Is your app architecture truly ready for the 2026 wearable revolution? It's a complex journey for sure, but the blueprint is right here. Thank you so much for joining me on this explainer. I really hope this leaves you motivated to evaluate and elevate your own health tech roadmaps. Until next time.